Hello students, parents and friends. Welcome to Concept Clarity for Physics. Today's topic is about motion in one dimension. This is an introduction session and later on we'll cover more depth about motion in one dimension and we'll also solve some problems as well. So in this particular session we will cover about the types of 1D motion, right? We will see what are the aspects involved, what are the actors in one dimensional motion. Then we will see a few aspects like reference point or position. And the next session we will study about distance and displacement in depth. So let us begin. I'll clear this out. Okay. Everyday life, everyday life, we experience motion, isn't it? How do we experience motion in our everyday life? Motion is the fact that I'm writing on the board is also motion of the pen. The pen is in motion, causing causing the friction between the board, and hence it is being displayed as light which you can see. The other types of motion is like playing football. Here the player is in motion. He goes um, left side, or he might go down, or he might kick the ball. The ball also is in motion, right? You could be walking on a footpath, right? So motion is experienced in our everyday life. So what are the types of motion? There are different types of motion, right? In this particular session, we are going to study types of 1D motion. So types of 1D motion. 1D motion indicates that the motion is in a straight line. It should be in a straight line. Okay, that is called as 1D motion, and it can be at different angles. Okay, for example, if I have a block on the road, if I have a block on the road, okay, if I push the block, then the block will observe a horizontal motion, right? Is there any other type of motion? Yes. I may throw a ball from the ground in the sky to the top, straight up. This is called as vertical motion. Then the third type of motion is if you have an inclined plane and if you have a block sitting here, it might experience either an upward or a downward motion, depending on which side the force is applied. So this is a slanting motion. So if you see here, all motions, all motion, whether it's horizontal motion or whether it's a vertical motion or whether it's an inclined motion, they are all in a straight line. So these are all examples of or types of one dimensional motion. So now let us look at what are the aspects of one dimensional motion. Who is involved in this particular motion? Let us see that. What are the actors? Actors of 1D motion. So to cause motion, you have you must have an object, right? And you should have an observer as well. When both are present, then only the observer can see the object in motion. So these are the actors of motion. Another important principle of motion is the position. This position gives the perspective of this motion, gives perspective. So depending on the position of the observer, he might see that the object is moving in a particular fashion. The object also could be in certain position, right? At what position that object is, whether what is the reference point taken for the object. Based on that, the distance where the object is currently placed at will differ, right? So position of both object as well as the observer. In this particular session for one dimensional motion, we are going to study more about the object. And in the subsequent topics, we will study more about the entire holistic aspect where the observer also is involved. Okay. So now let us talk about the aspect called as position. I'll clear this. If you have noted down this, I'll clear. Shall I clear? Yeah, I'm clearing it out. So now we're going to talk about position of the object. Now if I have an object, let us say that object is the ball here, a football. Do you like football? We'll say the object is placed here, the football. Now can you identify the position of the ball? Can you identify the position of the ball? It's not that convenient to identify the position of the ball by just looking only at the ball, right? We have to identify the position of the ball with respect to a reference point. We need to have a reference point. So let us say we have a goal post, not a perfect drawing. Okay, good enough. We have a goal post. This is a goal post, and this is the ball. This is the object of interest. The ball is the object of interest. So now I want to find out the position of the ball. So I have to tell the position of the ball with reference to the goal post, right? So then I can say the ball is at a distance d from the goal post which is placed on the left side, right? This is the left side. I can also say if I have another goal post here far away, in a football field there are two goal posts. This is the net, this is the net, right? So from here, the ball with respect to the goal post on the right side could be at a distance d dash, right? On the left side, there's a distance d from the goalpost on the left, and with respect to the goalpost on the right, it has a distance of d dash. So as we noticed here, that we need a reference point to identify the position of the object. right? So is this clear? So now if the object could be placed here, the object ball could be placed here. Now the position of the object with respect to this goalpost 1, this is goalpost 2, the position of the object with respect to goalpost has changed now. Now it will be d2 distance. d2 distance to the d2 distance from here, the reference point is here, right? d2 distance to the left. So this is how you identify the position of the object. You need a reference point to know the position of the object. Okay. So I'll clear this. So now the position of the ball can be either on the right side with respect to some reference, or it can be on the left side with respect to some reference, or it can be a top or down with respect to ground at the reference, right? So position gives the magnitude and direction of object, right? So direction, whether the object is on the left or whether it's on the right, or whether it's top with respect to the reference or whether it's down with respect to the reference, right? So that means position is a vector quantity. I hope so far it is clear. So I clear this. After this particular session, we will move on to distance and displacement. I'll be clearing it out. Let us summarize what we have studied. So one dimensional motion is a motion in straight line. It could be horizontal, it could be vertical, it could be slanting, right? Then we have studied the actors involved. We need the object which is of interest for motion, and we need the observer as well. And then we studied about the position with respect to reference point. Now, position with respect to reference point tells us the magnitude of how far the particular object with respect to that reference is. That means it tells us the magnitude, and it tells us on which side, whether it's on the left side or whether it's the right side, or uh, whether it is below or whether it is up. So it will tell the direction as well. So position is a vector quantity. So with this, we wind up for one-dimensional motion. This was just the introduction to one-dimensional motion. So in our next session, we will study about distance and displacement. We'll go a little bit in depth of one-dimensional. Clear the screen? Thank you. And do like, subscribe, and share.